The FIBO series of interferometers provide a complete solution for fiber optic connector end face testing and inspection. Combining high-resolution 3D geometry mapping, defect detection, and a visual inspection scope into one instrument simplifies the inspection process and results in a more accurate assessment of the optical connector. There are currently 3 models of FIBO to choose from to address requirements for field testing, production testing, as well as research and development. After installing the FIBO code software and drivers on a suitable computer, connect the FIBO to a spare USB 3 port. FIBO uses a unique system of interchangeable fiber connector adapters that use a kinematic mounting technology. The adapters are precision aligned at the factory, so no adjustment is required in the field. Magnets will hold the adapter in place and assure correct alignment. When the software is started on the computer, the FIBO will be initialized and a blue LED on the instrument will illuminate, indicating the unit is ready to use. In order to make accurate measurements, the FIBO must be calibrated before its first use. After that, further calibration should not be needed unless there are significant environmental changes or very heavy use. Calibration is performed using a set of 3 calibration targets that are included with the instrument. For a detailed description of this process, please refer to the user's guide. In the configuration bar, click on the small down arrow and select the type of connector to be tested. Insert the connector into the adapter until it is firmly seated. A live camera view will appear on the screen. The camera can operate as an inspection scope or display interference fringes prior to measurement and analysis. An on-screen switch selects the camera mode of operation. In scope mode, it is easy to see end face contamination and damage. If contamination is present, the connector should be cleaned prior to making any measurements. Switch to fringe mode to prepare to make a measurement. The camera must be properly focused to provide the clearest and highest contrast fringes. Focusing is provided by a set of on-screen buttons for either manual or autofocus. The arrow keys provide a fast focus up, slow focus up, as well as fast focus down and slow focus down. It is important to not tap these keys to prevent erratic operation of the focusing motors. Click and hold the desired key while watching the live camera view for the clearest fringe display. In addition to the manual focus keys, there are coarse and fine autofocus controls. A single click on the desired key activates the autofocus function. When proper focus is established, click on the 3D defect button to start a measurement. The fringes will change position during this process as the phase is changed and measurements are taken. When complete, a results screen will appear. At the top left of the screen will be either a green check mark or a red X indicating a pass or fail with details for radius of curvature, fiber height, apex offset, and end face defects. In the top center of the screen will be a 3D representation of the ferrule end face. Clicking in that view and dragging the mouse allows you to rotate the position of this topographical view of the ferrule end face. At the top right of the screen, the 2D grid offers views of the horizontal and vertical distance from the center of the fiber in microns, as well as the height at the point in microns. You can click in the image at the position you want to view, or drag the crosshairs to the position you want to view. The defects grid is located in the lower left part of the results screen, and it allows you to view the results with different parameters selected. Click the desired radio buttons to select your viewing options. The lower right grid of the screen displays the measurement results. All measurement data, as well as individual 2D and 3D images, may be saved for each measurement performed. Details on this and many other settings and features of the FIBO interferometer not covered in this demonstration are presented in the user's guide. FIBO interferometers are rugged, reliable test instruments designed to provide years of trouble-free service in all manufacturing, lab, and field applications. As the best instrument for verifying connector quality and suitability for service, FIBO interferometers provide the user with the confidence that system connectors will provide peak performance in mission-critical fiber optic systems.